All right, let's get into function transformations. I made some homemade guacamole last night. And I'm going to have some guacamole at the end of this video. I hope you have a treat for yourself at the end of this video too. All right, we're going to start by talking about horizontal shifts. So function transformations in general are just ways that we can transform functions. And so horizontal and vertical shift basically just says, if I give you a function, can you do that to it? Can you do that to it? How can you move it around, shifting it up, down, left, right, etc. So let's do some exploration. Let's look at a graph. So let's look at a graph over here. Let's say a parabola. I love parabolas. The question is, or the answer, let's see what happens when I, for example, add 1. If I add 1, this increases all the y values by 1, right? Y equals x squared plus 1 increases those y values by 1. And if we increase those y values by 1, what's happening to the graph? Well, it's just moving up and down. It's the same graph. Every single point, if you look at a single x value, all of those x values are just shifting up 1. And we could do this more, right? If I added 2, then all the x values are just going up by 2. Pick an x value. Maybe this x value, 1, 1. Oh, now it's 1, 3. And so on. We can move things down with negatives. And that's vertical shifts. And that's how we're going to start. Okay? We're going to start by making a giant table of a bunch of transformations. And in this table, we're going to have the transformation name. And we're going to have the definition. And we're going to have a little example. So make a giant table in your notes. It needs to have 10 rows. Okay, 10 rows are in this table. I don't know if I can fit 10 rows in mine. Maybe if I write small. And we're not going to do all 10 in this video, okay? But we are going to be doing 4 of them. All right. So first ones we discovered, vertical shift. Whoa, Shifu, that's not right. Shift up. And the second one is vertical shift down. So if we have a function and we want to shift it up, then we take that same function and then add a value. Similarly, to go down, right? Just like we saw, we look at a function and we subtract a value. We can use the examples that we did. We do x squared plus 2, right? That's up 2. If we did y equals x squared minus 3, that would be down 3. I should have just put this on multiple pages. I'm writing too small. All right, so that's vertical shifts up and down. So something that's going to be kind of a theme in this section is up, down, has to do with doing something on the outside. Left, right, has to do with something on the inside. So just like when we talked about function compositions, the inside of a function is a sort of nebulous concept. Let's look at something. If I have the square root of x and I add 2 on the outside of the square root, notice it moves it up 2. But if I add 2 on the inside of the square root, look what happened. If I add 2 on the inside of the square root, oops. If I add 2 on the inside of the square root, it moves it to the left. So that when we say inside, it's a horizontal shift because it's on the inside of the square root function. Similarly, right? If I add 2 on the inside of a parabola, the inside of that square, notice it moved that parabola left 2 units. Okay, any of our toolkit functions, add 2 on the inside is going to move it to the left. The new one, old one. That's a transformation right there. Any toolkit function you can think of. Absolute value, plus 2 on the inside, that moves that V to the left. That's going to be our next transformation, okay? Horizontal shift. So horizontal shift to the left and to the right. So to the left, it's a horizontal shift. If we add A, and again, you might think adding moves it to the right, but inside the function kind of usually works backwards from what you might think. So be very careful with these ones. So this is left A. To the right would be subtracting A. All right. So as some examples, we could do x plus 2 squared. That moves it left 2 units. Or we could do x minus 3 squared. That would be right 3 units. And that's this video. Let's do some examples utilizing these first 4. These first 4 transformations. Outside the function has to do with vertical. Inside the function has to do with horizontal. Let's get into it. So we're just going to look at a bunch of the problems from the homework. Okay, so we're going to start by looking at problem number 6. So for the October, I said I was going to have some guacamole after this. She's eating my chips. Chips and guac, not for you. All right. Anyway, for number 6, write a formula for the function obtained when the graph is shifted as described. So we have the square root of x. And what are we doing to it? We're moving it up 1 unit and left 2. So we're going to use what we did in the last video. To move it up 1, we add 1 to the outside. To move it left 2, we add 2 to the inside. What we're going to do is this new function is going to be left 2, means add 2 to the inside of the function. Up 1, add 1 to the outside. That's what that is. And that's what that is. And if we did our answer correctly, we should be able to graph it on Desmos and see if we're correct. Let's graph both of these functions. I can't move my mouse because it has chips on it now. All right, so if we go over back to here and we graph it on Desmos, the square root function is right here. What does our answer look like? The square root sqrt of x plus 2 plus 1. Is this purple graph? Left 2 and up 1? Yes, it is. Left 2 up 1 goes to here. And so on with every single point, right? This point, left 2 up 1 is on the purple graph. So that's how we know we did our answer correctly. It's a good idea to check your answers with Desmos. Next problem, number 8. 1 over x shifted down 4 and right 3. Down 4, right 3. So down 4 is minus 4 on the outside. Right 3 is minus 3 on the inside. Remember, anything on the inside sort of moves backwards from what you might think. But if you ever forget, just look at the table. Right 3 How do we find right 3? Subtract 3 on the inside. Okay. So let's combine all this out. We're going to get that our new function, our transformed function, there's no real inside, but for fractions, inside means denominator. It becomes x minus 3 on the inside or denominator and minus 4 on the outside of the fraction. Should look like this. Let's check our answers. Okay. Go back to Desmos and say, okay, now our toolkit function is 1 over x. If we subtract 3 on the inside and add 4 to the outside, are we moving the whole thing down 4 and right 3? Oh, wait. Should be a negative because that is not down 4. So the kind of middle used to be at 0, 0, and now the middle is down here, down 4, right 3. And you can pick some points. 1, 1, down 4, 1, 2, 3, 4, right 3. Ah, still on the graph. So the purple graph just got moved down 4 and right 3, as we wanted to do. All right. Next up, let's look at number 18. Oh, I don't have to scroll that far. Describe how the graph of the function is a transformation of the original function. So what transformations are being applied here in number 18? Well, let's look. 18 has y equals f of x minus 2 plus 3. So there's two transformations here. Minus 2 on the inside and plus 3 on the outside. So the question is, what are those? Plus 3 on the outside means up 3. Up 3. Minus 2 on the inside, let's look at our table. Minus 2 on the inside means right 2. And that's our answer right there. This is what's happening to the original graph. It's moving right 2 units and up 3. And we can do a couple more of different kinds. Let's do number 28. Okay, so you can sketch it with Desmos, but I do want you to write them both down on your own paper. Okay, so you can use the computer to help, but give a good graph on your own paper as well. H of x equals x minus 1 plus 4. Let's use, whoa, that's too small. All right, this is 24. H of x is the absolute value of x minus 1 plus 4. And then we want to graph both the original and the toolkit function. So the original, right? The toolkit function, the absolute value of x, right? That's a toolkit function that you should be familiar with at this point. But again, if you're not, you can use Desmos to help you. It's just this red graph right here. It's a V. Now, what transformations are being applied to it? Minus 1 on the inside means right 1. Plus 4 on the outside means up 4. So you can do this on Desmos, or you can just move this entire graph right 4. So right 1, and up 4. So now the V just starts here instead. All right. And the V goes up like this and up like this. I'm drawing over my problem. And that's what you should get here. And again, if you're not super comfortable with toolkit functions, you'll get there. But in the meantime, we can also look at it on Desmos, right? Vertical bar x for the absolute value. Yep, we had that. And y equals vertical bar x minus 1 plus 4. And this should look the same. We're not being consistent on our colors though. Well, let's do it, right? Let's make this red. Oh, there's no red. Purple's close enough. Make this other one blue. Great. Make sure the points are the same. And let's do another problem. Just more examples to really drive this home. Oh, that was 28. There we go. Nobody will notice, I'm sure. Do number 40. So number 40, what is it asking us to do? Write an equation for the graphed function using transformations. So we need an equation for this function using transformations. So, whoa, not white. This is number 40. So we're starting by identifying what toolkit function this is. And again, if you're uncomfortable with toolkit functions, look at section 3.2. That has all the toolkit functions here. It's a section on domain and range, but it's a good one. And one of them should look like this. All right, and once you kind of find that, you should be able to find that this is our toolkit. And then what's happening to it? Well, normally it starts at 0, 0. It's getting moved left 2 and down 2. So how do we write each of these? Left 2. Oops. We want to go left. That means adding 2 to the inside. Add 2 on the inside. We want to go down 2. That's going to be subtract 2 on the outside. Let's combine all this. What does our function become? The square root now has a plus 2 on the inside. Whoa. Now has a plus 2 on the inside. And it also has a minus 2 on the outside. Let's check our answer. Let's try to graph this formula and see if it looks the same. The square root of x plus 2 minus 2. Are these the same? Yep. There we go. That's function transformations. Let me know if you have any questions. I tried to give a lot of example problems, but questions are good. Bye-bye.